Welcome to Mars, 4 billion years ago, teeming with vast rivers and oceans. Today, it stands as a barren wasteland. What led to the disappearance of all that water, and could Earth face a similar fate? Throughout history, Mars was envisioned as a planet resembling our own, even a potential twin. Welcome back to Mars Discoveries, a channel dedicated to unveiling the hidden secrets of Mars and the universe around us. Before we dive in, don't forget to subscribe, like the video, and click the notification bell to stay updated with the latest Martian updates and news, including new discoveries. In the early days of astronomy, when observing Mars through primitive telescopes, astronomers believed they saw seas, continents, and even seasonal changes in vegetation. In 1877, Giovanni Schiaparelli labeled some features as canali, meaning rivers or channels. Percival Lowell took this quite literally, speculating that these strange marks might be canals constructed by intelligent creatures that inhabited the planet. It appeared that many people shared the belief in the presence of water on Mars. This lack of water posed a significant challenge for human exploration. Would astronauts need to transport all their required water from Earth? Could the Mars base or city produce enough water artificially to sustain itself? The dream of colonizing Mars suddenly felt distant. As we scrutinized Mars more closely, the mystery deepened. Orbiters revealed surface features that strongly resembled the work of flowing water, perhaps the very channels early astronomers claimed to have seen. Were these features truly shaped by liquids, or could there be another explanation? And if water once existed on the planet, where had it vanished to, and why? With each new probe and rover sent to explore the planet, the evidence supporting the idea that water had played a significant role in shaping the Martian landscape grew stronger. However, it wasn't until 2012 that NASA's Curiosity rover finally provided irrefutable evidence that liquid water had indeed flowed on Mars. While exploring its landing site in Gale Crater, Curiosity captured images of an ancient streamlet. The rounded and weathered pebbles found there could only have been shaped by liquid water. It became evident that Mars had not merely a small amount of water, but a significant history of it. In the early stages of the solar system, Mars and Earth may have been remarkably similar. So what transpired to transform Mars from a world of rivers into the desolate wasteland we see today? Is all water gone, or does some still exist? And if it does, where is it? This question was of paramount importance, prompting NASA's missions in the 1990s and 2000s to focus on one simple goal: follow the water. There were already indications that Mars wasn't entirely arid. In 1976, the Viking 1 and 2 landers confirmed the presence of water vapor in the Martian atmosphere. Additional experiments provided compelling indications of water chemically bonded within the Martian soil. Subsequent missions unearthed an increasing abundance of proof concerning water's presence confined within clays and minerals. On our home planet, volcanic and tectonic processes periodically release this water. However, Mars exhibits minimal, if any, such activity, causing the water to remain ensnared within the rocks and soils for countless millennia. This initial insight provided a vital lead regarding the whereabouts of the water. Nonetheless, water residing within rocks would not be adequate to sustain human life on Mars. Prospective explorers and settlers might potentially harvest a portion of it by subjecting the rocks to a process of literal rock cooking. Then in July 2003, the Mars Odyssey orbiter detected substantial amounts of water ice on Mars, providing undeniable evidence of frozen water just inches below the surface. These findings were reinforced in 2008 when the Phoenix spacecraft sent remarkable images from Mars' northern polar region, exposing ice hidden beneath a thin layer of dust. Further research at NASA's Jet Propulsion Laboratory suggests that there could be a massive reservoir of ice, up to 1.2 million cubic miles, at or near the surface, with even more buried deeper underground. However, one crucial mystery remains: the fate of the vast ancient oceans, lakes, and rivers that once graced Mars. Beyond studying the surface, scientists turned their attention to Mars' atmosphere, where they found clues that might explain the disappearance of the rest of the water. Since liquid water existed on Mars at one point in time, its atmosphere must have been much thicker and warmer than it currently is today. It is now believed that, lacking a protective magnetic field and ozone layer, Mars lost a significant portion of its atmosphere to solar radiation at an early point in its history. Water molecules in the atmosphere were destroyed. This gradually reduced pressure and allowed surface water to evaporate and to escape into space. As pressure and temperature continued to drop, liquid water could no longer persist on the surface. Over time, the oceans would have receded and frozen over, and this process of water loss continues even today. On Earth, water vapor evaporates from the surface, condenses into rain-filled clouds, and returns to the surface as precipitation. However, on Mars, water molecules are broken down and lost to space. Recent findings from the Mars Express orbiter have shown that dust storms and the planet's distance from the Sun can accelerate the rate of water loss. Over billions of years, water has gradually leaked away from Mars into space, causing its atmosphere to thin and its surface to cool. The remaining water either froze into ice, sank into salty underground lakes, or became locked within the planet's crust. Estimates of how much water remains on Mars vary widely, ranging from a few percent to more than 90%. The true extent of our knowledge will likely only be revealed through direct human exploration. What we can confirm, however, is that while Mars may no longer possess its oceans, it still retains some of its water resources. The key lies in knowing where to search for them. Fortunately, back on Earth, our planet's magnetosphere shields us effectively from the Sun's harmful radiation. Only further research, perhaps conducted by humans in person, can provide a definitive answer. From Earth, we have the capability to launch numerous missions to Mars to continue the search for any remaining water. The most recent mission aimed at this objective is the Mars 2020 mission, commonly known as the Perseverance rover. So far, it has captured stunning images, recorded peculiar sounds, and unveiled many secrets about Mars. In the vastness of space, the story of Mars unfolds as a tale of mystery, transformation, and exploration. As we journey through the pages of Martian history, we uncover the secrets of this once watery world and glimpse the potential for its future. The destiny of Mars serves as a reminder of the delicate balance that sustains our own blue planet. As we conclude our voyage through the enigmatic history of Mars, we invite you to join us on future expeditions to unlock more of the red planet's secrets. Subscribe and hit the notification bell to stay informed about the latest discoveries and the exciting possibilities that lie ahead in the quest to understand what happened to Mars. Thank you for joining us on this cosmic voyage, and always remember, the universe is vast, and its mysteries are boundless. Until next time, continue exploring, learning, and reaching for the stars.